In this lesson, we're going to be introducing Git. So the official definition is that Git is a distributed version control system. In other words, it's a way to keep track of all the versions of your project, and it can be used to collaborate with other people. So these are the two main features of Git. It's good for collaboration and for tracking the history of your work. So Git is a program that exists locally on your computer. Many people get confused thinking that Git and GitHub are basically the same thing. But this is a misunderstanding. They are two different things. So as we mentioned, Git is a program that exists on your computer, while GitHub is a company that provides hosting for projects using Git. This is so that you can host your projects on a remote server. In other words, you can host your projects that use Git on GitHub. So if we visit github.com, we can see that you can sign up to make an account on GitHub, and then you can host your projects that use Git on GitHub. So that's the difference between Git and GitHub. We will talk more about GitHub in a later section in the course, but for now, we're going to focus on Git. So to quickly overview, in this lesson, we covered what is Git and the difference between GitHub and Git. That was it for this lesson. See you at the next one. In this lesson, we're going to go over using the terminal and installing Git. Depending on what computer you have, Git may or may not be pre-installed. But even if you already have Git installed, you may have an old version and you may want to update to the latest version. Throughout this lesson, I'm going to be using the Finder window and the terminal. The Finder window is probably quite a familiar place for most people, but the terminal may be new, so I'm just going to quickly introduce it. So the terminal is a place where you type in commands and make things happen on your computer or see information. When you first open up the terminal, it's going to look something like this. At the very top, you have the prompt, and it's made out of three parts: the name of your computer, where you are in the file system, and the name of your user, followed by a $, and then a space where you can write commands. At the moment, we're in the home folder in our file system, and that's represented by this squiggly line. So the first command that we're going to use is git ---- version. This is going to tell us whether we have Git installed and which version we have installed. Another really helpful command that I'm going to be using is clear. This one just clears my terminal screen. So let's quickly see all of this in the terminal. So we can see that we're in the Finder window and we're in the home folder. And in the terminal, I'm also in the home folder. And I've actually simplified my prompt in order to just keep things more simple. Now I'm going to type in git ---- version. And we can see here that my Git version is 2.23.0. Now I'll type in clear, and it clears my terminal screen. So in my case, I already have Git installed. But if you don't have Git installed, or if you want to update to the latest version, it's really easy to do. You simply have to go to the git-scm.com website. Then you go to the downloads, and you simply download the right version for your computer. So that's how you install Git. Just to quickly overview, in this lesson we covered what the terminal is and installing Git. That was it for this lesson. See you at the next one. In this lesson, we're going to go over preparing the Git settings. So if it is your first time working with Git, there is one more thing you have to do before you start working on your first project using it. You want to set the name and email of your user in the configuration file or settings file. This is important because when you look at your project history, you will want to know who made which changes. But before we do this, let me introduce some other commands. So the ls command is a command that lists all the files in a folder. Let's see this in action. So we are in the Finder, and we can see all the files in the Finder. And also in the terminal, we can see we're in the home folder, and we type in ls. And now the files that we see in the terminal should be the same ones that are in the Finder window on the left-hand side. But these are all normal files, and there's another kind of file called a hidden file. Hidden files are files whose file name starts with a dot. In order to see them in the Finder, you have to press Command-Shift-Dot. And in order to see them in the terminal, you type in the ls command with the -a option. So in the Finder, you have to press Command-Shift-Dot, and then you can see all the hidden files that are grayed out. On the other hand, in the terminal, you have to type in ls-a, And here you can see, once again, all the hidden files. So now we covered how to see normal files and hidden files, but there's one hidden file in particular that I want to point out. So here you can see that we have a file called .gitconfig. Let's open it up. We can see that there's nothing in there. All it says is this is Git's per user configuration file. Now the next thing that I want to do is actually set the name and email for the user for our Git. So in order to do this, we're going to use a command, gitconfig. So the gitconfig command lets you see and set the Git options or settings. So in order to see them, you will write gitconfig and then the name of the option you want to see. And in order to set them, you will write gitconfig -- global, the name of the option, and the value that you want to give it. So let's see this in action. So first we're going to type in gitconfig user.name. So that's the name of the option. And we can see that there's nothing there. Now we type in gitconfig -- global user.name and pass in the value. We've set the value. So now if we type in gitconfig user.name again, we can see that it gives us this value. And now if we open up the .gitconfig file, we can see that it set the name for our user. Now let's do the same for email. Gitconfig -- global user.email and then pass in the value. And now if we open the .gitconfig file once again, we can see that now the email is set as well. So that was how to set the username and the email so that when we use Git, we know who made which changes. To quickly overview, in this lesson, we covered how to set the name and email we want to use with Git. That was it for this lesson. See you at the next one. In this lesson, I'm going to go over making our project directory. So if we want to start working with Git, first we need to have a project folder or a project directory that we will actually track with Git. A directory is simply another term for folder, so I will be using these two terms interchangeably. So let's see how we would normally create a folder in the Finder. We would probably right-click, create a new folder, and pass it a name. Here I'm calling it Git Learning Journey. But in order to do the same thing in the terminal, we have to use a command. And the command we use is mkdir, which stands for make directory, and then we pass in the name of the directory that we want to create. So let's see this in action. Let's first go and delete the folder we just created in the Finder. And then we go into the terminal. In the terminal, we can see that we're in the home folder, and that's where our folder will be created. And we type in mkdir, and then the name that we want the directory to have, Git Learning Journey. And what we just saw on the left-hand side is that our project directory was just created. So we've created our project directory, and you may notice that I've used camel case in order to give it the name. And that means there's no spaces, and each subsequent word, the first letter, is capitalized. Now I did this because in the terminal splits the arguments you write by the white spaces. So if I'd gone in and wrote an mkdir Git Learning Journey, including the white spaces, we can see that it would have made 3 different folders, each with one of the words. So I just quickly wanted to point that out. So now we've created our project folder, and we want to see how we can go into that project folder. So in the Finder, how I would normally go into a folder is to double-click. So now in our Finder window, we're inside the Git Learning Journey folder. A quick thing to point out here is that navigating throughout the file system is an independent process in the Finder and the terminal. In other words, when I go into and out of folders in the Finder, that doesn't affect anything in the terminal, and vice versa. At the moment in the Finder, I'm in the Git Learning Journey folder, but in the terminal, I am still in the home folder. So in order to go into a folder in the terminal, we're going to use another command, the cd command, which stands for change directory, and then we pass in the name of the directory we want to go into. So let's quickly see that. So we can see right now that we're in the home folder in the terminal. And now if we type in cd Git Learning Journey, we can see that now we're in the Git Learning Journey folder. So we just saw how to go into a folder, But we also want to see how to go out of a folder. So in the file system, a single dot represents the directory you're currently in, your current directory, and double dots represent the directory before, or the parent directory. So in order to go to the previous folder, we'll use the double dots. So now we go into the terminal, we pass in cd dot dot, and we can see that we're back in the home folder. But we actually want to be in the Git Learning Journey folder, so we're going to type in cd Git Learning Journey, and now we're in the Git Learning Journey folder once again. So that's it. We've created our folder and we're inside that folder at the moment. That was it for this lesson. Let's quickly overview. In this lesson, we went over how to make a directory and how to navigate through the file system. And we also introduced the mkdir command and the cd command. That was it for this lesson. See you at the next one. So in this lesson, we're going to go over creating or initializing a repository. We start the lesson having already created our project folder, which is called Git Learning Journey. And what a Git repository really is just a folder inside your project folder, and it's called .git, so actually it's a hidden folder, and it tracks all the changes to the files in your project. So the command to initialize a repository is git init, so let's see this in action. We have to be inside the folder that we want to create a repository within, and that's the Git Learning Journey folder. And we want to show all the hidden files, so I press Command-Shift dot, there's no hidden files, and in the terminal, I can write ls-a, and once again, no hidden files. We only have a dot, which represents the current directory, and a double dot that represents the parent directory. So let's go and type git init. And here we can see that we have initialized an empty Git repository. And on the left-hand side, we can see that the .git folder was created. So now, if we go into the terminal and we type ls-a again, we can see the .git folder is there. So we've created our Git repository. Now I want to make a quick note about the git init command. If you pass the name of a directory to the git init command that doesn't yet exist, then the command does two things. First, it creates the directory, and then it also initializes a Git repository within it. So let's see this in action. Let's first go and delete the project folder. And then we go into the terminal, we're in the home folder, and here we type git init, Git Learning Journey. And we can see that on the left-hand side, the Git Learning Journey project folder was created. We go inside and we press Command-Shift dot again, and we can see the .git folder is there. And if we go to the terminal and go into our project folder, and we type in ls-a, we can see the .git folder is there as well. So now let's take a quick peek as to what's inside this .git folder. So this is a bunch of stuff which at the moment may seem like gibberish, but in the next coming lessons, we're going to go over what some of these folders and files are for. So just a quickly overview, we created a Git repository, and we learned the git init command. So thanks for watching, and see you at the next lesson. In this lesson, I'm going to go over how to add a file to our project. We start the project with our project folder and our repository, and I want to quickly distinguish between the two. So the contents of our project folder, the folders and files we find within it, are represented by something called the working directory. So the working directory is sort of like a workbench. It's where you work on your files, you edit them, you add new files, you delete files. On the other hand, our .git folder represents our repository, and I want to introduce two places within the repository. First is the staging area. So the staging area is sort of like a rough draft space. Whenever you're done working on a file in your working directory, you want to add it to your staging area, because then once you have all the files you want in the next version of your project in your staging area, you are ready to save them in the next version of your project, which is called a commit. So a commit is basically a version of your project, and each commit has a 40-character hash, which is just 40 letters and numbers, which are unique, And this hash acts like a name for the commit. It's a way to refer to it. So the commits are in something called the commit history. And in order to add a file to our repository, first we add it to our project folder, so it goes into our working directory. Then we add it to the staging area, and then it becomes a part of a commit in our commit history. So now we're ready to add our first file. I'm going to use a source code editor called Visual Studio Code. And I've decided I'm going to create a file called journey.txt, and I'm just going to add some text to it. So we open up our source code editor, open up the folder. Now we create a new file. I'm going to call it journey.txt. And on the right-hand side, you can see that this file was created. And at the moment, it's empty. There's nothing in there. We haven't added any text. So let's go and add some cheesy text. We are just starting this learning journey, exclamation point. And now if you look on the right-hand side and we look into the file, we can see that the text is there. So the file we have in our source code editor is the file that we have in our project. Awesome. So we've added a file to our working directory, but this file is not yet in our repository. So no changes to this file are being tracked yet. So now to quickly overview, in this lesson we covered adding a file to our project, and we went over terms such as the working directory, what is the staging area, and what is a commit. That was it for this lesson. See you at the next one. In this lesson, I'm going to go over making our first commit. So we start off with our project folder, our repository, and one file in the project folder. Our file, however, is only in our working directory. It's not yet part of our repository, and we're not tracking any changes to it. So our first git command that we can use, which will actually tell us the state of our working directory and of our staging area, is git status. So git status will tell us the state of our working directory and our staging area, and it will let us know if there are any differences between the two. Let's see this in action. We go into the terminal, we type in git status, and we can see it tells us there's no commits yet, but there are untracked files. It also yet tells us to use git add to include in what will be committed, and it shows us our journey.txt file. So our journey.txt file is untracked, it's not yet being version controlled, and it also told us to git add in order to include in what will be committed. So what's this git add command? The git add command copies a file from the working directory into the staging area. So let's see this in action. We type in git add and pass in the name of the file. And what we just saw is on the right-hand side, an index file was created, and that's actually our staging area. So now we type in git status, we see that there's still no commits, but now there's changes to be committed, and it's telling us we have a new file, journey.txt. So what we just saw now was our file was copied from the working directory into the staging area, and we saw that a new file was created called index. And index represents the staging area. They are the same thing, and those two terms can be used interchangeably. So now, if we're happy with all the files that we have in our staging area, and those are the ones that we want to save in our next version of our project or in our next commit, then we're ready to make our commit. It's important to note that commit is actually a verb and a noun. So to commit something is to save something, and a commit means a version of our project. So the command to make a commit is git commit-m, and then you pass in a message, usually making some sort of comment about the changes that you made. So what the git commit command is going to do is it's going to take a snapshot of your staging area, and then it's going to assign a hash to the commit it's going to make from that snapshot. And it's also good to know that you don't need all 40 of the characters in that hash. You only need a few of the first ones to refer to your commit, usually about 7. So let's see this in action. We go into the terminal, we type in git commit-m, we pass in a message. Here I'm saying adding first file. And here we can see the hash, 183D64F. These are the first 7 characters of the hash. And if we go into our .git folder, I want to show you the objects folder because that's actually where all our commits are. That's actually what represents the commit history. So what we just did now is we took a snapshot of the staging area and we created our commit, which has the hash 183D64F. So now to overview. In this lesson, we made our first commit, and we used commands such as git status, git add, and git commit. That was it for this lesson. See you at the next one. In this lesson, I'm going to go over working with an existing project. So you can see that I have a folder called novel and 4 files inside, each representing a chapter. Let's go into that folder in the terminal. So we're inside the folder now, and we can see that if we type git status, it tells us that this project is not a repository. We're not tracking any of the changes to these files at the moment. So here we have our working directory with our 4 files. And what we want to do is we want to initialize a repository so we can track all the changes to these files. So I go into the Finder and I press Command-Shift-Dot to show any hidden files. And then I git init, and here we have our repository. Now the next thing we want to do is we want to start tracking all the files in this project folder. So we want to make an initial commit with all the files. We can use the git add command, and we can actually pass in a directory to this command. And if you recall from a previous lesson, a single dot represents our current directory. So we're going to pass in the single dot to the git add command. We can first do git status, which will tell us that none of these files are being tracked. And then we can git add dot, which adds all these files to the staging area. So now if we write git status, we can see that all these files are in our staging area and they're ready to be committed. Now let's just go and make our commit. We type git commit -m, pass in our message. Mine's just initial commit. And we can see it gives us our commit hash. And if we type git status again, we can see that our working tree is clean. So there we go, there's our commit. But now let's assume that we want to make some changes to our 3rd and our 4th chapters. So we go to those files and we make some changes. And we save those changes on our computer. So now we have a new version, an updated version of these files. And now the working directory and the staging area, the files in each of them are different. And the git status command will tell us this. So we go into the terminal, we type in git status, and we can see that it warns us about this different in the version of the file in our working directory than in our staging area. So let's add these updated files to the staging area. We go in, we write git add dot, and now if we type git status, it tells us that it has updated files that it's ready to commit. So there we go. But what if we now decided that we actually don't want to add all the changes that we made to chapter 4, and we actually want to unstage that file and take it out of the staging area? We can do this using the git reset command, typing head -- and then the name of the file. So let's see that. We go in the terminal, we type in git status. We can see that we have these updated files, but now we decide to take chapter4.txt out of the staging area. And there, we've unstaged that file. Now we type git status, and we can see that in our next commit, we'd only include the updated version of the chapter 3 file. So there we go. So this goes to show that we can move things in and out of our staging area. And that's why in a previous lesson, I'd referred to it as a rough draft space, because you can really decide what you want to include in the next commit or the next version of your project. So now, if we're happy with all the files we've added to our staging area, then we're ready to commit. So let's do our commit. Git commit -m, pass in the message. Here I'm just going to say updates to chapter 3. It gives us our commit hash. And we can see our commit in our commit history. So now just to overview, In this lesson, we covered tracking an existing project and removing files from the staging area. And we also showed one use of the git reset command. That was it for this lesson. See you at the next one. In this lesson, I'm going to go over what is a branch. So let's create a new repository. I'm going to call it cold colors, and I'm going to list some cold colors that I know. So let's go to the editor and open up our new project folder. I'm going to create a file called colors.txt. And I'm going to name some cold colors that I know. So blue is a cold color. So at the moment, our repository has no commits in it. But before we make our first commit, I want to point out something really important. A commit stores a snapshot of all the files in your project at a particular point in time. It does not just store the things you changed from one version of your project to another. And this is a really important feature of Git. It means that every commit in Git is like a standalone version of your project. So now that we pointed that out, let's go make our first commit. Let's go into the project folder. In the Finder, let's show all our hidden files, so Command-Shift dot. And I want to show one folder in particular. Inside the refs folder, inside the heads folder, there's nothing there at the moment, but we're going to get back to that in a second. Now let's add everything to our staging area. And now let's make our commit. I'm going to pass in the color blue as the commit message. So there, we made our commit. It's given our commit hash, which is 161EA15, and it's telling us that the commit is on branch master. So in that folder, inside refs, inside heads, there's a file called master now. Let's click into that. So here we can see the hash of our blue commit, 161EA15. So now we see we have a commit with a commit hash 161EA15, and we have a branch called master pointing to it. It's really important to note that master is not some kind of special branch. It's simply the default branch that Git gives you. It's the default name that it gives that branch. And also I want to point out that I'll be using the color that I pass into the commit message as the color of the commit in the diagrams, just to make it easier for me to reference the commits. So now, what is a branch really? A branch is a pointer to a commit. It's really important to say that a lot of people think of branches as similar to tree branches, but this can be a very misleading mental model to have. They are simply pointers to commits. They're nothing like tree branches. So now, let's overview. In this lesson, we covered what branches are, so they're pointers to commits, and we also mentioned that commits are snapshots of all the files in your repository, and not just changes. That was it for this lesson. See you at the next one. In this lesson, we're going to go over making a commit on a branch. So at the moment, we have one commit, and our master branch is pointing to it. But before we make another commit, let me introduce another useful command called git log. So git log lists all the commits made in our repository in reverse chronological order, and it also shows us all the branches and which commits they point to. So let's see that in the terminal. We're going to type in git log, and we can see our blue commit with its commit hash, the author, and the message. And we can see that master points to this commit. So now what happens if we make another commit? We're going to go in and say purple is a cold color. And now we can just quickly show the master file. It still simply points to our blue commit with this commit hash. And now let's add everything to our staging area. And let's make another commit. I'm going to pass in purple as the commit message. And we can see here we have our commit hash A16FE3F, and it's on branch master. So now if we go into the master file again, we can see that the commit hash in here is that of the purple commit. It's A16FE3F. And if we type in git log, we can see our purple commit with its commit hash, and that master now points to the purple commit. So we have our purple commit, and now master points to it. So in other words, whenever we make a commit on a branch, the pointer of that branch moves to the latest commit. Another important thing that we see here in our diagram is that the purple commit points back to the blue commit. And that's because commits reference their parent commit. And the parent commit of the purple commit is the blue commit. We can use a command in order to explicitly see this. This is a command you won't use very often, but it's git catfile -p, and then we pass in the commit hash. So let's see that. We're going to just do git log so we have easy access to the commit hashes. I'm going to copy this, and I'm going to write git catfile -p and paste in the commit hash. And here we can see our purple commit, and we can see that it references the parent, and it gives us this commit hash, which is the commit hash of our blue commit. It's 161EA15. So there we go, we have our two commits. Let's quickly overview. What we covered in this lesson was making a commit on a branch, and the fact that commits point back to their parent commit. We also introduced a really important command, which is git log. That was it for this lesson. See you at the next one. In this lesson, we're going to go over making a branch. So we have our repository with two commits and one branch called master pointing to the purple commit. Now, before we go to make our second branch, let me introduce a really important command. The git branch command will list all the branches in our repository, and it will also tell us which branch we are on because it will make the name green and it will have an asterisk next to it. So let's see that. We go into the terminal, we type in git branch, and we can see that we are on the master branch. There's an asterisk next to it and it's green. And that list should be the same as the list under the heads folder. Now, the git branch command is actually also the command we use to make a branch. If we pass in a branch name that does not yet exist to the git branch command, then git will make that branch, and also that branch will be pointing to the commit that we are on when we make the branch. So let's see that in action. We'll go into the terminal, we'll type in git branch. We can see we only have a master branch. And now we'll type in git branch again, but we'll pass in the name of a branch that doesn't exist. So I've decided to call it feature1. And now on the right-hand side, we can see that a new file was created in the heads folder called feature1. Let's click into it. We can see that it has a commit. It's pointing to the purple commit with a hash A16FE3F. So now if we go into the terminal and we type in git branch again, we can see that feature1 is there. But notice that we are still on the master branch. We can see this if we type git log. Now, both our master branch and our feature1 branch point to the purple commit. And there's also this thing called head in capital letters. We're going to get to that in a second. So we can see that there's a new branch called feature1 pointing to the purple commit. Now, what is this thing called head in capital letters? So head is a pointer to a reference of which branch you are on. So let's see that. We can go to the file called head, and if we click into it, we can see that it tells us that we are on branch master, has a reference to this branch. And if we go into the terminal, we can see that head is a pointer that's pointing to master. So now we have another pointer called head pointing to master. And that was it for this lesson. Let's quickly overview. In this lesson, we covered making a branch and what head is. And we also introduced an important command, the git branch command. That was it for this lesson. See you at the next one. In this lesson, we're going to go over switching branches. So we have two commits in our repository and two branches, and currently we are on the master branch, but we want to switch into the feature1 branch. The command we're going to use to do this is the git checkout command, and we're going to pass in the name of the branch we want to switch into or to check out to the command. So the command is going to do three things. It's going to change the head to point to the new branch. It's going to populate our index or staging area with a snapshot of the commit we're going to switch into. And it's going to copy the contents of your index into the working directory. So that all sounds very complex, but it actually looks quite simple. Let's go check it out. So we go into the terminal and we type in git branch. We can see that we are on our master branch. And if we look in the head file, We can see that it references our master branch. So now we're going to type in git checkout and pass in the name of the branch we want to switch into. So we've now switched into the feature one branch. So if we write git branch again, we can see that that's the one that has the asterisk next to it. And if we check out head again, we can see that now it references the feature one branch. Let's type in git log to see this more visually. We can see that now the head points to the feature one. So now we've switched into the feature one branch. How about we make another commit? So we're going to say that green is a cold color. We're going to save, add the updated file to our staging area, and make our commit, and I'm going to pass in green as the commit message. And now we can see that we have our commit hash 97D789D, and that this commit was done on the feature one branch. So now let's do a git log. So now we can see that we have our green commit, and our feature one branch points to this commit now, but our master commit still just points to the purple commit. So we have our commit, and now feature one points to the green commit. We had also mentioned that the git checkout command does three things. It changes head to point to the new branch, and we recently saw this, and it populates our index or staging area with a snapshot of the commit we're switching into, and then copies the contents of your index into the working directory. In other words, when you switch branches, the contents of your working directory changes. Let's see this in action. So let's do a quick git log. We see that feature one points to the green commit and master points to the purple commit. So now if we git checkout master, we'll see in our editor that the version of the file we have there only references blue and purple as cold colors. If we then git checkout feature one again, we're going to see that green is also included as a cold color. So we have that version of the file in that commit. Then git checkout master again. Once again, we only have the version of the file that references blue and purple as cold colors. So this is a really important point to make. When you switch branches, the contents of your directory changes. That was it for this lesson. Let's quickly overview. In this lesson, we covered checking out other branches and the fact that switching branches changes files in your working directory. We also introduced an important command, the git checkout command, and that was it. See you at the next lesson. In this lesson, we're going to cover merging a branch. So we have a repository with 3 commits and 2 branches, and right now we are on the feature one branch. So what exactly is merging in Git? Merging is when you incorporate the changes made on one branch into another branch. So you have one branch you are merging and one branch you are merging into. The branch you're merging into is the one that receives the changes, and therefore it's actually the only one that is altered in this operation. So in our case, we want to merge feature one into master. And note that since we made the feature one branch, it's the only one that we have added commits to. So master has no new commits on it. This means that when we merge feature one into master, it will be a fast forward merge. So what exactly is a fast forward merge? Well, when we make a branch from a commit that another branch points to, and we only add commits to one of those 2 branches, then we do a fast forward merge when we merge them. This is a simpler kind of merge, and all that happens is the branch pointer of the branch that we're merging into is going to move to the latest commit. So let's see that. The first step to doing a merge is to switch into the branch we want to merge into. So if we are merging feature one into master, we have to check out master. In other words, switch into the master branch. So we can see right now that we are on the feature one branch, and we're going to git checkout master, and now we're on the master branch. Now, the command that we're going to use in order to do the merge is git merge. And we pass in the name of the branch we want to merge in. In our case, that's feature one. So let's see this in action. I'm going to type git log -- all. And here we can see that master points to the purple commit, and feature 1 points to the green commit. And in our editor, we can see that we only reference blue and purple as cold colors. Now, if we type in git merge feature 1, we can see that the commit hash that feature 1 points to has been updated and that it was a fast forward merge. And in our editor, now we also mentioned that green is a cold color. We have the updated file. So now, if we type in git log again, we can see that both master and feature 1 now points to the green commit. So now we've merged feature 1 into master, but we can see that our feature 1 pointer, our feature 1 branch is still there. That's because it doesn't get deleted after we merge it in. We have to go and explicitly delete it ourselves. So in order to do that, we're going to use another command. It's the git branch command with the -d option, and we're going to pass in the name of the branch that we want to delete. It's important to note that you can't be on the branch you want to delete. You have to switch onto another branch before deleting it. In our case, we can see that we're actually on the master branch, so we can already delete the feature 1 branch. We can see the list of branches in our heads folder, so we just type git branch -d feature 1. And now we can see in our heads folder that there's no feature 1 file anymore. So now we only have a master branch. That was it for this lesson. Let's overview. So in this lesson, we covered merging a branch, deleting a branch, and what is a fast forward merge. And we introduced a new command, the git merge command. That was it for this lesson. See you at the next one. In this lesson, we're going to introduce VI, or Vim. In a previous lesson, we mentioned that when we want to make a commit, we use the git commit command with the -m option, and then we pass in a commit message. But what happens if we forget to write a message? In this case, Git is going to open up something called VI, or Vim. This is a text editor, and it's usually going to open up when we use Git when we forget to write a commit message or when we're doing a merge. In it, there are two modes, normal mode and insert mode. When you open it up, it's going to be in normal mode. In this mode, anything you write will be interpreted as a command. In order to be able to write your commit message, you have to go into insert mode. And in order to do that, you have to press I. Then you enter insert mode, and there you can write your commit message. And in order to save and then exit the editor, you have to go back to normal mode. In order to do that, you have to press the escape key. So let's see this. We are in a repository called test, and Git status will show us that we have some files staged for commit. So now we type in git commit, and we forget or don't pass in a message. So now we are in VI, and we're in normal mode, so anything we write right now will be interpreted as a command. Now we can press I to go into insert mode. And at the very bottom, you can see the word insert, and that's how you know you're in insert mode. Now we can go to the very top, and we can write our commit message. And now in order to go back to normal mode, we have to press the escape key. So now the word insert is gone. We are back in normal mode. And in order to save and quit, we have to put a colon and WQ. WQ stands for write and quit. So now if we do a git log, we can see that our commit with a commit message is there. So to quickly overview, in this lesson, we covered the basics of using VI. That was it for this quick lesson. See you at the next one. In this lesson, we're going to go over doing a three-way merge. So what is a three-way merge? Well, in a previous lesson, we had covered doing a fast-forward merge, and that is possible when, from the moment that two branches diverged, you've only added commits on one of the two branches. Now, if we add commits to both of the two branches, then you have to do a three-way merge. And in that case, you create a merge commit, which is a commit that can have more than one parent, and this commit will tie the two divergent development histories together. So, a merge commit is a commit that can have more than one parent. Let's see this. So we start off with a repository, which I have called primary colors, and in it I have one commit, the blue commit. And in my file, I've written that blue is a primary color. Now, the next thing we want to do is we want to create a branch and check it out in one go. In order to do that, we're going to use the git checkout command, but we're going to use the -b option and pass in the name of the branch we want to create and check out. So let's see that. We can see that at the moment we're on master. We're going to type in git checkout -b feature 2. And now we can see that we've actually created the feature 2 branch and we are on it now. So we make the branch and we switch onto it. Now let's add a commit on the feature 2 branch. So I'm going to go in and type that red is a primary color. I'm going to add it to the staging area, then commit. The commit message is going to be red. And here we've made our commit on the feature 2 branch. Now, in order to create divergent development histories, we're going to go on the master branch and we're also going to add a commit there. So we check out the master branch. And here I'm going to create a new file, call it info.txt, and I'm just going to write that these are the primary colors. Add everything to my staging area and make a commit. So there, we checked out master and we made another commit on master. Now we can see that we've added commits to both the master branch and the feature 2 branch. So now we decide we want to merge the feature 2 branch into the master branch. Let's see how we do that. So we can see that we are on the master branch. And now we type in git merge feature 2. We see that VI opens. We decide to keep the default message and to save and quit. And now we can see that if we type git log, the master branch is pointing to a new commit. This is our merge commit. And we can see that it has 2 parents. So there we have it. We have our merge commit, which ties the 2 divergent development histories together. Now, to explicitly see the fact that it has 2 parent commits, we can use a command that we used in a previous lesson. Let's go see that. We're going to do git log to grab the commit hash. And we're going to type git catfile -p and pass in the commit hash. And here you can see we have 2 parent commits. So that was doing a 3-way merge. Let's overview. In this lesson, we covered how to do a 3-way merge, and we introduced the merge commit. That was it for this lesson. See you at the next one. In this lesson, we're going to go over merging with conflicts. So merge conflicts arise when you make different changes to the same file in the branches that are involved with a merge. In our previous example, when we had divergent histories and we had to do a merge and we did a 3-way merge, we had actually made changes to different files. In this lesson, we're going to go over what happens when we make changes to the same file. So we have a repository called secondary colors, and I'm going to make a file called colors.txt, and I'm going to write that green is a secondary color. And I'm going to make the first commit. So here we have our green commit, and our master branch is pointing to it. Next, I'm going to create and switch into a new branch called feature 3. And now I'm going to make a commit on the feature 3 branch. So we go in and we type purple is a secondary color. And I make another commit. Now let's switch back into the master branch. And let's make a commit on the master branch. So we can see here we switch into the master branch. We're only referencing green as a secondary color. And now we're going to type that orange is a secondary color. We're going to make a commit. So now we've made a commit on the master branch and on the feature 3 branch. And in both branches, we've actually changed the same file. So let's see. So here we can see the changes we've made to the colors.txt file in the feature 3 branch and the master branch. In the feature 3 branch, we mentioned that purple is the secondary color, and in the master branch, we reference orange as a secondary color. So this time around, when we try to merge the feature 3 branch into the master branch, we're going to have a merge conflict. So what's going to happen is we're going to have conflict resolution markers around the content that has been changed. We're going to have to decide which content to keep. So on the top of the conflict resolution markers, we're going to have the content that's in the branch we're merging into. And in the bottom markers, we're going to have the content of the branch that we're merging in. And we're going to have to get rid of the conflict resolution markers and decide what content we want to keep. Once we're happy with the content that we've edited, we can add all the changes to the staging area and commit. So let's see all of this in action. So we're already on the master branch, so we git merge feature 3. And now on the right-hand side, we can see all the conflict resolution markers with the content we need to edit. Let's first get rid of all the markers. And now we edit the content. In our case, we're going to choose to keep everything. We save. Now we add our changes to the staging area, and we make our commit. We're just going to choose to keep the default message. So we're going to save and quit. And now if we type in git log, we can see that we have a merge commit with the 2 parent commits, and our master branch is pointing at it. So now we just saw how to do a 3-way merge where you have to resolve conflicts. One last note before we finish this lesson. If you're in the middle of a merge and you decide that you want to stop it or abort it, then you can use the git merge command and pass in -- abort. In that case, you will stop the merge. So that was it for this lesson. Let's overview. In this lesson, we covered merging with conflicts, and we introduced terms such as what is a merge conflict really, and the conflict resolution markers. That was it for this lesson. See you at the next one. In this lesson, I am going to introduce remote repositories. Up until now, we've only worked on our repositories on our own, and we've only kept them on our computer, locally. This kind of a repository is called a local repository. So a local repository is one that exists on your computer, on your local machine. But if you want to collaborate with other people or back up your repository somewhere other than your computer, you need to use a remote repository. So a remote repository is one that's hosted in a remote location, for example, on a server. There are different services that provide hosting for remote repositories, but the most common one is GitHub. So GitHub is a company that provides hosting for projects using Git. So the local repository is on our local machine, and the remote repository is in a remote location. Now there are 2 ways to start working on a project with Git. You can either use the git init command and create the repository locally. In this case, you then push it up to a remote location. Otherwise, you can use another command, the git clone command, which will clone or copy a remote repository onto your local machine. So you find a repository remotely that you want to work on, and then you clone it or copy it to your local machine. So those are 2 different ways of starting to work on a project with Git. Let's quickly overview. In this lesson, we covered the difference between local and remote repositories and 2 ways of starting to work on a project with Git, and we introduced the git clone command. That was it for this lesson. See you at the next one. In this lesson, we're going to go over how to connect to GitHub using SSH. So when working with GitHub, you will have to identify yourself using your username and password. But if you don't want to have to enter your username and password every single time, you can use SSH authentication. But first and foremost, if you don't yet have a GitHub account, then it's good to go and create one. You can do so at github.com and simply follow the instructions to create an account. Now, before I continue, I want to point out that I will be following the official GitHub instructions on how to set up SSH authentication, and you can easily find those by Googling GitHub SSH, and it should most likely be the first link. Then you can go to the right article. So here you'll see that they have the instructions for Mac, Windows, and Linux, and they have all the commands that we're going to use throughout this lesson. I'll be using the Mac instructions in particular. So there are three main steps to setting up SSH authentication. First, we're going to create a public key and a private key pair. Second, we're going to add the private key to the SSH agent. And third, we're going to add the public key to GitHub. So let's start with the first step, creating the public-private key pair. So we're going to jump into the terminal, and we're going to type in ssh-keygen-t RSA-b 4096 C, and then pass in the email that we use with GitHub. So the T stands for type, the B stands for bytes, and the C stands for the label. And you're going to pass in your email. Enter, and we can see that it tells us it's generating the public-private RSA key pair. And it's telling us which file to save it in. You should usually just choose the default, so enter. And now on the left-hand side, we can see that there's a new folder that's been created, .ssh. Now it wants us to enter a passphrase or password, and then once again. And there, we've created our private public key pair. Let's just quickly go and look at this .ssh folder that we saw. In here, we can see our private key and our public key. Let's quickly look into them. This is the private key. And this is the public key. So now let's move to the second step. We're going to add the private key to the SSH agent. The SSH agent will manage our SSH keys and remember our passphrase. So first we have to start the SSH agent in the background. So we're going to do this by typing eval open quotations $, open parentheses, SSH agent -s, close parentheses, close quotation marks. So now it's started. Now we have to change our SSH config file to automatically load keys into the SSH agent and store our passphrase in our keychain. To do this, we're going to type in nano, squiggly line, / and then pass in the path for the config file. Here, I'm gonna paste in the things that I've copied from the GitHub instructions. And now to exit, press Ctrl X, and to save, press Y, and to exit, enter. Now we have to add the private key to the SSH agent, and we're going to do this by passing in the command ssh-add -k, and then the path to the private key. We enter our passphrase, and there, we can see that our private key has been added to the SSH agent. Now let's move on to the third step, adding the public key to GitHub. So first we want to copy our public key, so we're going to use the pb copy > and then the path to the public key. Now we've copied it to our clipboard, and we can go to GitHub. You could also open up the .ssh folder and just copy it from the file. Now let's go to GitHub. So in GitHub, you're going to go to the upper right corner to your account, and you're going to click on there. Then you want to go to your settings, click on there. In the settings, you're going to go to the left-hand side to the option that says SSH and GPG keys. There, you're going to get a list of your SSH keys. You may not yet have any. And you're going to go to the top right where it says New SSH Key. You're going to add in a title for this key and paste in the key that you just copied. And finally, you're going to add SSH key. So that means you'll have added your public key to GitHub. So that was it for this lesson. Let's quickly overview. In this lesson, we covered how to set up SSH authentication with GitHub. From now on, you will no longer have to use your username and password every single time you want to connect to GitHub. That was it for this lesson. See you at the next one. In this lesson, we're going to go over adding a remote repository. So we have a local repository called Citrus Fruits, and we have one commit in it, the orange commit. So there's our local repository, and there's our orange commit with our master branch pointing at it. Now, if we want to start working with a remote repository, we actually need to create that remote repository in the first place. So let's go do that in GitHub. We go to create a new repository. We're going to give it a name. I'm going to call it citrus fruits. And we're going to decide whether it's going to be public or private. And then we're going to create the repository. GitHub is going to give us a URL, which is sort of like an address for our remote repository. So there it is. We've created it. But the thing is that at the moment, the local repository and the remote repository are not actually linked. So the local repository is unaware or does not know of the remote repository. The command that's going to show us this is git remote. So this command shows us the remote repositories that are linked or tracked by our local repository. But we will also use this command in order to add a remote repository. We're going to do this writing git remote add, passing in a name, and then the URL. It's important to note that when you clone a repository, the default name that Git gives a remote repository is origin, and often people use this name even when they add remote repositories themselves. So we're going to use that name. Let's go see this. So we can see in our config file that there's nothing mentioned about our remote repository there. And now if we go into the terminal, we type in git remote, there's no remote repositories. But now we're going to type in git remote add origin, which is the name, and paste in the URL. And this time around, if we write git remote, there, our origin remote repository is there. And in the config file, we can see it's there with the URL. So now we've created a link between our local repository and our remote repository. Let's overview. In this lesson, we covered how to add a remote repository, and we used the git remote command. That was it for this lesson. See you at the next one. In this lesson, I'm going to go over pushing to a remote repository. So we can see that we have our local repository with our commit and our master branch pointing at it, and we have a remote repository, but the remote repository doesn't have any commits in it. We can also see that our local repository has a link to the remote repository. Now, in order to push our master branch to the remote repository, we're going to use the git push command. We're going to pass in the name and then the branch that we want to push. What this is going to do is it's going to create a remote branch in our remote repository. And another thing that's going to happen is that in our local repository, we're going to get a new branch, and this is going to be a remote tracking branch. So remote tracking branches are local branches, but which are references to the state of a remote branch in a remote repository. We'll talk more about that later in the lesson. So now if we go into GitHub, we can see that we have no commits here. And now if we go into the Finder folder, I quickly want to point out in the refs folder, we only have a heads and a tags folder. So now if we type in git log, we can see that we have our master branch pointing to our orange commit. Now let's git push origin master. And we can see on the right-hand side that a new folder was created in the refs folder. It's called remotes, and inside that there's a folder called origin, and inside that there's a master file. This is our remote tracking branch. And now in the terminal, if we type in git log again, we can see that we have our master branch pointing to the orange commit, but we also have a new branch, the one in red, called origin/master, and this is a remote tracking branch. So now if we go into GitHub and we refresh, we can see that we have one commit, and it's the orange commit. So now we have a remote master branch, and we also have a remote tracking branch in our local repository called origin/master. So remote tracking branches are local references that you can't move. Git moves them for you whenever you do any network communication. So in other words, if you push a branch or if you fetch or pull down any changes. You can think of them sort of like bookmarks that remind you where the branches in your remote repositories were the last time you connected to them. So that was it for this lesson. Let's quickly overview. In this lesson, we covered how to push to a remote repository. We used the git push command, and we introduced the term remote tracking branch. That was it for this lesson. See you at the next one. In this lesson, we're going to go over how to update a remote repository. So we can see our remote repository and our local repository, and they're both in sync at the moment. Now let's see what happens if we make another commit. So in GitHub, we can see we just have our orange commit. Now let's do a quick git log. We can see that our master branch and our remote tracking branch are both pointing to the orange commit. Now let's make another commit. So lemons are yellow. Add our updated file to the staging area and make our commit. Now if we type in git log, we're going to see that our master branch points to the new yellow commit, but our remote tracking branch still points to the orange commit. And remember, in a previous lesson we mentioned that remote tracking branches represent the state of remote branches. So if we look at our remote branch in GitHub, we can see we just have the orange commit. There's no yellow commit there. So we can see our commit and our master branch being updated. But the remote branch and the remote tracking branch are still pointing to the orange commit. And that's because remote repositories are not automatically updated. We need to explicitly push our changes. So let's go see that. Just do a quick git log again, showing our master branch pointing to the yellow commit and the remote tracking branch pointing to the orange commit. And now we do git push origin master. So we push our changes to the remote repository. And now if we type in git log again, we're going to see that our remote tracking branch has been updated and is also pointing to the yellow commit. And if we go into GitHub and we quickly refresh, we can see that our yellow commit is there. So there we go. We've made our yellow commit and we've pushed it to the remote repository. And now our remote branch and our remote tracking branch are updated. So now, to quickly overview, in this lesson we covered how to update our remote repository. That was it for this lesson. See you at the next one. In this lesson, we're going to go over working with others. So we have our local repository and our remote repository, and they're in sync. And now we're going to look at what happens when someone else wants to contribute to our project. So let's add a coworker. In order for a coworker to get a version of our repository on their local machine or computer, they will have to clone it with a git clone command. So they're going to type in git clone, pass in the URL of our remote repository, and then they can optionally pass in a directory name. If they pass in a directory name, then their project folder on their computer will have that name. Otherwise, it will have the name that we gave the repository when we created it. So the git clone command is going to create a project folder, it's going to initialize the repository, and it's going to pull down all the data for the repository, so each version of every file for the history of the project. Also note that the default name that it's going to give the remote repository is origin. So let's see this. We go into GitHub, we can go where it says clone or download, and we're going to copy this URL. Then we're going to go to the terminal. We can see we are in the home folder. Also in the Finder, we're in the home folder, and actually you can see our citrus fruit repository there. I'm going to create a new repository pretending to be a coworker. So git clone, pass in the URL, and I'm going to call the repository coworker. So now if we go to the right, we can see that a new project folder called coworker has been made. And we can go into it in the terminal as well. Type in git log, and we can see that both our commits are there. So here, our coworker has cloned the repository onto their computer. Now let's see what happens when our coworker decides to make a commit. So we can see we're in the coworker repository, both in the terminal and in the editor. We can see that there's the two commits there. The coworker decides to add some work, so limes are green. They're going to add, commit, and now git log will show us that our master branch points to the green commit. And the remote tracking branch, though, still points to the yellow commit. So we can see that the coworkers repository has a green commit, the master branch now points to it, but the remote tracking branch still points to the yellow commit. And that's because, as we mentioned in a previous lesson, remote tracking branches represent the state of remote branches. And if we look at the top at our remote repository, we can see that there's no green commit there. The remote master branch still points to the yellow commit. And also, if we look at our repository, the citrus fruits one, there's no green commit there either. Let's go and see this explicitly. So we're in GitHub, and we can see that there's no green commit here. And now if we quickly go out of the coworker repository and into the citrus fruits, and we type git log, we can see that there's no green commit here either. So in order for our coworker to share the work they did in their green commit, they have to push it to the remote repository. Let's see that. So here we can see we have just 2 commits. We're back in the coworker repository. Quick git log will show us that the remote tracking branch still points to the yellow commit. And now we do git push origin master. And now if we do git log, we can see that the remote tracking branch is now pointing to the green commit. And if we open up GitHub and we refresh, we can see that the green commit is there too. So we have our green commit in our remote repository, and our remote master branch and our remote tracking branch have been updated. But we can also still see that the green commit is still not in our repository, in the citrus fruits repository. Let's go see this explicitly. So we're in the citrus fruits repository, we type in git log, and there's no green commit here. This is because these updates don't happen automatically. We need to explicitly get or fetch changes from remote repositories. So that was it for this lesson. Let's quickly overview. In this lesson, we covered someone else cloning the repository and contributing to the project. That was it for this lesson. See you at the next one. In this lesson, we're going to go over fetching changes. So we can see that in our coworkers repository and in the remote repository, there's a green commit, but in our repository, in the citrus fruits repository, we don't yet have the green commit. So we want to go and fetch it. In order to do this, we're going to use a command called git fetch. We're going to use git fetch, and we're going to pass in the name that we've given our remote repository, which in our case was origin. The important thing to note is that the git fetch command only fetches the data. It doesn't actually merge it in. You have to do that explicitly. So let's go see this. We can see that we're in the citrus fruits repository. And if we do a git log, we can see our master branch and our remote tracking branch point to the yellow commit. Now we're going to type in git fetch origin. We can see that some updates have occurred. And if we type in git log again, now we can see that our remote tracking branch has been updated and it points to the green commit. But our master branch still points to the yellow commit. And if we look on the right in the editor, we can see that we have the version of the file that's in the yellow commit, not in the green commit. So we can see that we have a green commit and our remote tracking branch points to it, but the master branch still simply points to the yellow commit. And that's because when you use the git fetch command, you simply fetch the data, you don't actually merge it in. We have to explicitly merge the changes into our master branch. So in order to do that, we're going to use the git merge command, and this time we're going to pass in the name of a remote tracking branch. So let's go see that. We do a quick git log again, we can see where our branches point to. And now if we type in git merge and pass in the name of the remote tracking branch, origin/master, now if we do another git log, we can see that both our master branch and our remote tracking branch point to the green commit. And if we look to the right, we can see that we have the updated file, the file that was in the green commit, in our editor. So now our master branch also points to the green commit. That was it for this lesson. So to quickly overview, in this lesson we covered how to fetch changes from a remote repository, and we introduced the git fetch command. That was it for this lesson. See you at the next one. In this lesson, we're going to go over working at the same time as others. So we have a new repository called Berry Fruits. Our repository is at the bottom left, and it's actually named Berry Fruits. We have a remote repository, and we have a collaborator that has cloned the repository, and I've named that repository Collaborator. This repository has one commit, the red commit, and the master branch points to it. So now what happens if both me and my collaborator try to contribute to the repository on the master branch at the same time? So let's say our collaborator adds a commit. We can see that we're in the collaborator's project folder, and there's a file called berry.txt. We've written that strawberries are red, and this is the version of the file that's in the red commit. Now our collaborator adds more work. Blueberries are blue. They save and they make a commit. So here we can see the blue commit. The master branch is updated, and they also push the commit to the remote repository. But what happens now if I also try to work on the master branch and push it to the remote repository? First, let's make a commit. We can see now that we're in the Berry Fruits repository, so our repository, both in the terminal and in the editor. We have the version of the file that's in the red commit. And now we add work as well. Raspberries are pink. We save. We add the updated file to the staging area, and we make our commit. And now we want to try to push to the remote repository. But we are unable to push to the remote repository, and this is because Git warns us that there's work in the remote repository on the branch we're trying to push that we have not yet fetched or pulled down. We have to first fetch all the changes, and then we can push our master branch. So we can see that we have the pink commit in the local repository. The master branch now points to it, but we are unable to push this commit, this updated master branch, to the remote repository. First, we have to use a command called git pull to pull down the changes. We could also use the git fetch command and the git merge command like we did in a previous lesson, but the git pull command does both a git fetch and a git merge in one go. So we're going to type in git pull, the name of our remote repository, and the branch that we want to fetch the changes for. So let's see this in action. We go into the terminal, and we type in git log. We can check that we have the two commits. And now if we type in git pull origin master, it's going to fetch all the changes, and it's also going to do a git merge. And we can see that because we and the collaborator both touch the same file, we have conflicts. So let's go resolve those conflicts. Let's get rid of the conflict resolution markers, and let's decide what to keep. We're going to keep everything for now. Let's save. And now we add the updated file to the staging area, and we make our commit. I'm going to pass in the commit message resolving conflicts. And now if we do a git log, we can see that our master branch now points to this new merge commit. We can see that it's a merge commit because it has more than one parent. And our remote tracking branch still points to the blue commit that it fetched. So we can see that we fetched the changes, and then when we were merging, we made a merge commit. Now we want to push this to the remote repository. We can see in the remote repository in GitHub that we only have two commits. And now we git push origin master. This time around, we're able to push our changes. And now if we go into GitHub and we refresh, we can see that all the commits are there. So we pushed all our changes up to the remote repository, and we can see that now our collaborator, if they want to stay up to date, they have to fetch all the changes from the remote repository. So let's see that. do a quick git log, we can see that in the collaborators repository, there's just 2 commits. And now we do git pull origin master. It's going to fetch all the changes, and it's just merged them in. So now we do another git log. We can see all the commits are there. So we can see it fetched all the changes, and then it merged them in, and our master branch now points to the latest merge commit. So in this lesson, we saw that whenever we collaborate with other people on a project, and for some reason we work on the same branch, we first need to always fetch their changes before we're able to push our own. We have to stay up to date with the work that has been done, and then we can contribute more. So now let's quickly overview. In this lesson, we covered working at the same time as someone else, and we introduced the git pull command. That was it for this lesson. See you at the next one. In this lesson, we're going to go over rebasing, and this is part 1 of a 2-part lesson. In a previous lesson, we had a repository whose commit history looked like this. We started off with a red commit, and then 2 people joined the project. One person made the blue commit, another person made the pink commit, and then in order to combine their work, a merge commit was made. Now, if the commit history of a repository has a bunch of merge commits, it can start to look very messy. So the question is, how can we maintain a linear commit history? Something that looks more like this. We can do this by using the rebase command. So first, let's start with a new repository. We have a new repository called Rainbow, and we've pushed it to the remote repository, and a colleague has cloned the repository as well. Now, let's assume that we want to make a commit. So we are in the Rainbow repository. We can see that we're in the Rainbow project folder. We have a file called rainbow.txt, and we've written that the first color of the rainbow is red. So this is the version of the file in the red commit. Now let's add some work. We say that the second color of the rainbow is orange. We save, and we make our commit. We also push our commit to the remote repository. Now let's assume that our colleague also wants to do some work. So we can see that we're in the colleagues project folder. They have the version of the file that's in the red commit, and they write the third color of the rainbow is yellow. They save, and they make a commit. Let's assume that they want to add some more work. So they're also going to write that the fourth color of the rainbow is green. They're going to save, and they're going to make another commit. So our colleague has added 2 more commits. Now if our colleague fetched the changes in the remote repository that are on the master branch and merged them into their local master branch, a new merge commit would be made. In order to avoid this, they can use rebase in order to maintain a linear project history. So they would write git rebase and pass in the name of the branch that they want to rebase onto. What the rebase command does is it takes all the changes that were committed on one branch and replays them on another branch. In our case, our colleague is going to fetch the changes from the remote repository, but instead of merging them in, they're going to rebase their local master branch onto the remote tracking branch. So the first thing we need to do is fetch the latest commits on the remote master branch so our remote tracking branch updates. So let's go do that. So they're in the terminal, we're in the colleagues repository, we write git log, we can see that the master branch points to the green commit, and the remote tracking branch points to the red commit. We're going to fetch all the changes, so git fetch. Now if we type in git log, we can see where the local branches point to, but if we type in git log -- all, we can see that our master branch points to the green commit, but now our remote tracking branch points to the orange commit that we've fetched. So let's focus on the colleagues repository. The colleague fetched the changes from the remote repository, and now we have the orange commit. So let's go over the 5 steps of the rebase command. The first thing that Git is going to do is it's going to find the common ancestor of the 2 branches, the one we're on and the one we're rebasing onto. In our case, that is the red commit. Then the second thing it's going to do is it's going to get the diff, or the changes introduced by each commit of the branch we're on, which is the master branch. And in our case, that's the changes made by the yellow commit and the changes added by the green commit. Then the third thing is it's going to save those changes, those diffs, to a temporary file. Finally, the fourth step is it's going to reset the current branch, so our master branch, to the same commit as the branch we are rebasing onto. So that's the orange commit. And finally, the last step is it's going to apply each change in turn. So first, the changes introduced by the yellow commit, and then the changes introduced by the green commit. It's really important to say that when it reapplies these changes, these are entirely new commits that are made with new commit hashes. And because they're entirely new commits, there is the golden rule of rebasing. So the golden rule of rebasing says that you should never rebase a public branch. Because rebase creates entirely new commits, this can cause major problems, especially when working with other people. You should always ask yourself, is anyone else looking at this branch? And if the answer is yes, you should maybe reconsider rebasing. In our example, our colleague has not shared the yellow and green commits. They are only in their local repository, and so they are only rebasing local changes before pushing them, which does not violate the golden rule of rebasing. So that's all I want to cover in part 1 of this lesson. In part 2, we're going to go over how the rebasing process happens in the terminal, and we're going to sync the rest of the repositories. So see you there. This is part 2 of the rebasing lesson. In part 1, we introduced what is rebasing, and we did a walkthrough of a rebase example with a diagram, and we covered the 5 steps of the rebasing process. So now let's look at our colleague's repository before rebasing. We can see that the master branch points to the green commit and the remote tracking branch points to the orange commit. And now our colleague is going to rebase their master branch onto the remote tracking branch. So let's go see that in the terminal. They're going to go in and they're going to write git rebase and pass in the name of the remote tracking branch. Now we can see that in the terminal it tells us that first, rewinding head to replay your work on top of it. So what Git has done is it's gone to find the common ancestor of the two branches, which in our case is the red commit. It's gotten the diff introduced by each commit of the branch we're on, so that's the changes introduced by the yellow commit and by the green commit. It's saved those changes, those diffs, to a temporary file, and it's reset the current branch to the same commit as the branch we're rebasing onto. So it's reset to the orange commit. We can see that it's now applying the changes of the yellow commit. And in our editor, we can see that we have conflicts, merge conflicts. So now let's go resolve those conflicts. Let's get rid of the conflict resolution markers. And we can decide what to keep. We're going to keep everything in this case. We're going to save and add the updated file to our staging area. Then we're going to type in git rebase -- continue. We can see that it applied the yellow commit changes, and now it's applying the green commit changes. Once again, there are conflicts. Let's go resolve them. We can choose what we're going to keep, save, add the updated file to the staging area, and git rebase -- continue. We can see that it applied the changes of the green commit. So now our colleague's repository looks like this. We have a linear commit history. Now, in order to see a list of all our commits, we can go back in the terminal and type in git log. And here we can see all the commits. Note that the commit hashes for the red commit and the orange commit are the same as before, but the commit hashes for the yellow commit and the green commit are different. We can see this with a side-by-side comparison. Here we can see that the commit hashes for the red and the orange commit are the same, but the ones for the green and the yellow commit are different now. Now let's push these changes to the remote repository. So we can see in GitHub that there's just the red and the orange commit. We are in the colleagues repository. We git push origin master. And now if we go back to GitHub and we refresh, we can see that the commits are all there. The final step is for us to fetch the changes into our Rainbow repository. So we can see we're in the Rainbow repository, and we're going to type in git pull origin master. And we can see that this was a really simple fast forward merge. And in the editor, we can see the most up-to-date file. So there we go. All our repositories are in sync, and this was an example of rebasing. Let's quickly overview. In this two-part lesson, we went over rebasing, the golden rule of rebasing, and how to maintain a linear commit history. That was it for this lesson. Thanks for watching. In this presentation, we're going to go over the solution to the merging exercise. So in part 1, you want to first check what branch you're on. We're on the chapter 2 branch. And you want to check out the master branch in order to merge the chapter 2 branch into the master branch. So now you're going to use the git merge command to merge the chapter 2 branch into the master branch, and we can see that that was a fast forward merge. And finally, you want to delete the chapter 2 branch using the git branch command with the -d option. Next, in part 2, we want to create and check out a branch in one go, so we use the git checkout command with the -b option, and we make a branch called chapter 3. Now we add a new file called chapter3.txt, add some text, and then save the file and make a commit. So add the file to the staging area, git add, and git commit. My commit message here is just added chapter 3. Next, we want to go to the master branch, so we use the git checkout command to switch to the master branch. And let's add some text to one of the other files. Here I'm just saying this is chapter 2 of my story. And let's make another commit. Add the file to the staging area and make a commit. So now we've made a commit both on the chapter 3 branch and on the master branch. And so now when we decide to merge the chapter 3 branch into the master branch, this is going to be a three-way merge. So we're going to use the git merge command to merge the chapter 3 branch into the master branch. And we're just going to use the default message. And now if we use git log, we can see that this three-way merge created a merge commit, which means that the merge commit has 2 parent commits. So now in part 3, just quickly check we're on the master branch. And what we're going to do is we're going to make some changes in the chapter 3 file. So in my case, I'm going to write, this is my 3rd chapter, save the file, and make a commit. So add the file to the staging area, and make a commit with a git commit command. Here I'm just passing in the message added to chapter 3. And then what we're going to do is we're going to switch into the chapter 3 branch. So git checkout chapter 3. And we're going to make changes to the same file, so to the chapter3.txt file, but we're going to make different changes. So here I'm going to write in chapter 3 ... and save the file, and then make another commit on the chapter 3 branch. So add the updated file to the staging area and make a commit. So now we've made changes to the chapter 3 file and made a commit both in the master branch and in the chapter 3 branch. And the next thing that we're going to do is we're going to merge the chapter 3 branch into the master branch. In order to do that, we have to be on the master branch. So we're going to check out the master branch. And then using the git merge command, we're going to merge the chapter 3 branch into the master branch. What's going to happen is we're going to have conflicts. So we have the conflict resolution markers here. So we're going to get rid of those and choose what we want to keep. In my case, I think I'm just going to keep this is my 3rd chapter and get rid of the other changes. And then now we can add this updated file to the staging area and make a commit. So in this case, we did a 3-way merge with conflicts, and we had to resolve these conflicts. So my message here is resolve to chapter 3 conflicts. And now if we do a git log, we're going to see that we have, once again, a merge commit with 2 parent commits. So that was it for this exercise. See you at the next lesson. In this presentation, I'm going to go over the solution to the remote repositories and working with others exercise. So you want to go and create a new repository and then give it a name and then click the Create Repository button and then copy the URL it's going to give you. So you go into GitHub, you copy this URL, and then you can go to your book repository, your local repository. You can use the git remote command to check whether your local repository is linked to any remote repositories. Here we can see it's not. So then we would use the git remote command again to add this link to the remote repository. And now we can see that our remote repository and our local repository are linked. Now we want to push our master branch to the remote repository. So we use the git push command to do that. And finally, we can go into GitHub. And if we refresh, we can see that all our commits are there now. So now we're going to create a new repository, and we're going to need this URL for the remote repository, which is the same URL as before. Just to show you now, we have all our commits here. And we're going to create a new repository, so let's go back to the home folder. And we're going to use the git clone command to clone the remote repository. And we're going to call it editor. So then we're going to go into our editor repository. And in our source code editor, we're also going to want to open up this new local repository. And what I'm going to do is I'm going to make a new file, and it's going to be called notes.txt. So these are going to be like the editor notes for whatever the editor has to say about the chapters. So I'm going to type in these will be the editor notes and save this file. Then I'm going to go and make a commit in this editor local repository. And I'm going to want to push this commit to the remote repository. So I'm going to push my master branch to the remote repository with the git push command. And now if we go into GitHub and then we'll refresh, we'll see that our new commit is here. So now as the author of the book, I want to fetch the changes that my editor made to the repository. So I'm going to go into the book local repository. I'm also going to make sure that in my source code editor, I have the book local repository open. And then I'm going to use the git fetch command to fetch the changes from the remote repository. And I'm going to pass in the name of the remote repository that I want to fetch changes from. If we use the git log command with the -- remotes option, we can see that now our remote tracking branch has been updated to point to the latest commit in the remote repository, but the local master branch is still pointing to the previous commit. So now I'm going to merge those changes into my local master branch with a git merge command. And now if I use the git log command again, I'm going to see that both my master branch and my remote tracking branch are pointing to the latest commit that was in the remote repository. That was it for this exercise. See you at the next lesson. In this presentation, we go over the solution to the working with a local repository and branches exercise. This is just one way of solving it, so let's go check it out, but you may have taken a slightly different approach. So the first thing we want to do is to make a project directory, so we use the mkdir command. Then we go into that directory using the cd command. And finally, we initialize a repository using the git init command. Then I go to my source code editor, and I open up my book project folder. Now I want to make a new file, and I call this file chapter1.txt. And then I go into that file and I add some text. You can add any text you like. And I save the file. And then I make my first commit. So I add the file to the staging area, and I make my first commit, and I pass in the message added chapter 1. Great, so now we can see we have one commit in our repository. Then I'm going to go and make some more changes to the chapter1.txt file. You can add any text you like. And I'm going to go and make another commit. So I'll add the updated file to the staging area and make another commit. This time my commit message is going to be added to chapter 1. So now if we type in git log, we can see that we have 2 commits. The next step is to make a branch. And to do that, I'm going to use the git branch command. So we can see that we have just one branch at the moment, but now we're going to make a second branch called chapter 2. And we're going to check out this branch using the git checkout command. And now I want to go into my source code editor and add another file called chapter2.txt. And here I'll add some text. You can add, once again, whatever text you like, save the file, and make another commit. So add this file to the staging area and make a commit, and my commit message is going to be added chapter 2. So now we can see if we want to list all of the commits, we're going to use the git log command, and we can see that we have 3 commits in total. And if we want to look at all the branches we have, we use the git branch command. So now for the optional section, We initially have just one commit, and the master branch points to it. That's in stage 1. And we're on the master branch, so the head pointer is pointing to the master branch. Then in stage 2, we make a second commit, so the master branch moves to point to the latest commit, and we're still simply on the master branch, so the head pointer is still just pointing to the master branch. In stage 3, we make a second branch. So now, not only do we have the master branch pointing to our latest commit, we're also going to have a second branch called chapter 2 pointing to the latest commit. But note that we're still on the master branch. So in stage 4, we actually switch into our chapter 2 branch. So you'll see that we're no longer on the master branch, so the head pointer will be pointing to the chapter 2 branch. And finally, in stage 5, we're going to make another commit. So in total, we're going to have 3 commits. And since we're on the chapter 2 branch, when we make that other commit, the chapter 2 branch will move to point to the latest commit. So that was the solution for this exercise. See you at the next lesson.